Just say some things. Like, anything.
I'm a bit of a boogie. Here, getting ready for the Project Hex presentation.
Okay, everyone. Welcome to the first official Hex General Meeting to end our first semester. The first thing I'm going to ask all of you is that we will be recording the session. Is everyone okay with being recorded and putting it onto the uni website? If not, then I think if you sit over there, you'll be out of the camera view.
Actually, if you sit over here, because the camera in the back's in the back of your heads, but this one here will get like front. So if you're not comfortable, if you go sit over the back left. But if everyone's happy, then
yeah,
cool. I'll start recording.
Cool. I'm assuming everyone's okay with that. So just a couple of announcements first. So as I mentioned before, we've got our first SSI social tomorrow. It's going to be in Bar 1 and Pop-Tarts from 8 PM. So if you go to that, you can either go to both or just one. That's entirely up to you. And yeah, obviously we've also got our Christmas dinner that some of you have already signed up for. But if you haven't, then unfortunately that's already gone. So cool. Let's get started. So I don't want to take too much time from the more important bits. So to start off, I've done a little really quick recap of what we've done in terms of stats and numbers to make it easy to understand. So first of all, we started with 6 members at the end of last year. Because of COVID, we had a very hard time getting to workshops. Obviously, a lot of people left. We were at, I guess, an all-time low within the society. But then we got the summer concept team back in of 15 people who laid the foundations for where we are now with over 50 people in our team, which is the highest that I think Hex has ever been, as far as I'm aware. So that's just incredible. Obviously, we're a drone team, so we build quite a lot of drones. I think in total, we're working currently on a dozen different drones, from UGVs to micro, little tiny ones that you guys have been building, all the way up to things like Big Bryony and the Hex that we're assembling. I mean, I've been asked by quite a lot of people from our teams, like, is Hex like a drone club? Because you guys make so many drones. Like, do you actually build one big drone? And the answer is all of these are actually contributing towards making that one big drone. Whether that's getting training with the smaller ones, testing on stuff like Talon and Big Brian, or even using, as a testbed aircraft down the bottom right there, which is the one we got from 3DX very recently. So I think that's something we should be really proud of, because the more we build, the more we learn, and the better we actually do at the competition. So in terms of events we went to this year, so we went to 6 different events. That goes all the way from the activities fair all the way up to the International Advanced Engineering Conference that Josh and I represented Hex from. And this is just the start. We've got plenty more planned, which operations team will be going through with you. In terms of sponsors, at the start of this year we had just the uni, and now we've got a whole array of different sponsors providing everything from materials to finances, and we've raised over 6,000 so far this semester, with much more on the way, as operations will be telling you more about. And just to mention, I think Aerostructures, we've got Easy Composites now on the team, and also carbonfibertubes.co.uk will be providing us with the main booms for the actual aircraft, so a really important structural component. But yeah, so I'll hand you over to the Aerostructures team to take a look at their progress.
Cool. Right, so I'm Josh, I lead the Aerostructures team. So we've been making some cracking progress this year. We've been doing so much stuff, it's absolutely ridiculous. So started off with, had a rough aero design, knew roughly what we were doing, had a little bit from the concepts team, which actually went a lot further than we expected throughout the summer, so we could really hit the ground running with things. Aero, I've really been pushing ahead with CFD, which will have more later. Manufacturing, we've been cracking on with working out how exactly we're going to make our wing. And then structures, we're doing an incredible job of actually making the whole modernist airframe. We've got an incredible design which we'll be showing you guys later on for those who haven't seen on Hex Bulletin. So we've got Jack, Tom and Shrey, who are our structures, manufacturing and aerodynamic leads, and they'll be running through the rest of the presentation. So I think Shrey's up first, but if you guys want to. It's on the back screen, so you've got
So Aero team has done like a pretty good job over the last like 4 months. I'll just show you the timeline real quick. From August, like doing the summer concepts team, we're doing prelim design, and now we're over in December, and we've already kind of got a wing design, like a scale model of a wing done, which Structures manufacturing done a great job with. We've been doing iteration 2 sizing, which is kind of just taking the iteration 1 we've got and then tweaking it, making sure it's like the correct size. We're very confident in its flight performance right now. So, we've been using X-Plane. A few of you have already been to the X-Plane tutorials that Oscar hosted very kindly. And X-Plane's been kind of paramount for us just to be able to visualize the dynamic stability of the aircraft and how it flies. So, I think the 3D XR visit was also really great. We got some good ideas from there. Oscar did mention that we can increase cruise speed a bit. As for next steps, we want to look into doing wing twist and stuff. Wing twist and wing tip sizing is kind of important for us just to bring down the stall speed a bit more. So, sorry, bring up the stall speed. Bring down, let me say. Bring down the stall speed. Yeah. What was I going to say? Yeah, CFD is in a good place. We've got some CFD results, which you can see in the previous screen over here. Rupesh has done a great job with that. And yeah, we've also got one last thing to say, which is the wind tunnel. We'll be heading there in February, I think. We had a talk with Rob just now, a few days ago. That was a great talk, and he's happy to support us. I'd like to get like the first and second years on that project, because I think it'd be a great way for you guys to get involved with like hands-on experience, understanding Reynolds numbers and stuff, and how they scale up and down. But yeah, that's it for Aero. If you have any questions, hit me up later.
Yeah, just as about the other note, guys, if you have any questions about anything that goes on, if you jot them down and then we can talk about those at the end, just so we keep the flow of the presentation going.
Yeah, so I'm Jack, the manufacturing lead. We haven't got as far as we wanted to. This is problems, and again, I apologise to all the manufacturing guys. We wanted to get with composites this semester, but things just haven't worked out that way. But we have made progress getting the third scale wing done, working on the rest of that. That's James's projects at the back, his kind of little one he's working on. We also started working out more of the preparation stuff to make the carbon fibre stuff, and really getting into how we're going to do it. So it's been a lot more of the preparation for the composites, which really leaves us in a better position for a second semester where we'll crack on. We'll talk a little bit about that in a minute, but it's really been the preparation kind of phase. We've also been working a little bit on converting talent. Again, that's more preparation stuff, and then that will be worked on more in the second semester. That's going to recap for manufacturing.
So for those who don't know me, I'm Tom, I'm the structures lead. This semester we've pretty much built up from what the summer concepts team did with the Aero design, and we've pretty much got a full airframe, as Josh said. This is sort of an out-of-date model, but it's the last pretty looking model. As those who've had access to Fusion and have been looking around, our current model's looking a bit messy. That's because we're working on a lot of new concepts, and we're working on all the joining methods, such as joining the wings to the booms and the tail to the booms as well. But it's all going well. Yeah, we've got CAD of everything. We've done a bit of FEA on the booms and the wings, just to see the deformation really, and how it will act on the forces. But yeah, that's about it. But we're doing really well, and it makes us really good.
So we'll talk a little bit about the future work and that sort of stuff. So Aero, so we've been working on iteration 2 at the moment. So that's been, Shrey said, a lot of CFD, looking into a little bit of sort of basic wing tip analysis, a little bit of whether we need force generators, that sort of thing. And next semester we're really going to be charging ahead with iteration 3, which is going to be working on a little bit more sort of control surfaces stuff, doing even further refinement, testing of stuff in wind tunnels, so we can add on little bits to our scaled down wings, see how that all works out. We can do some visual analysis as well as testing out Talon, so we'll have a full testing program with Talon, and we can compare that to all of the data that we've actually already been working on in the simulation, so we can see how everything works with better models, and we can really pushing ahead with that. Talk through a little bit.
Yep. So manufacturing is all going to be about really building up the prototypes. So first we'll work on kind of a non-composite, so just working with sort of vinyl, those sort of materials, build up a proper one-to-one full prototype, or not working prototype, but something we can really just show off and see what we're doing. And then it's all going to be geared towards making the carbon versions. So that's going through making the wings. We need to work out exactly how we're doing it, but it's going to be done next semester. That's kind of our plan at the moment, is really getting into it, making those composites. And also, as I said, finishing Talon as well, getting that fully done so we can test that, use our Avionics test bed finally.
So, at the start of next semester, the structures team should have a full airframe completely done, the wings as well. We'll hand that over to you guys in manufacturing, so we can sort of get version 1 up and running. Once we've got the structure done, actually, we'll talk about mass. Yeah, so we want a mass estimation as well, as soon as possible, so we can sort of get further design. And so I've got a Google Sheets running. So for those other teams, so Avionics and Electronics, if you've not seen it, keep filling out that when you've got a sort of component mass, and that'd be great. Soon, also at the start of next semester, we'll have a radio tail attachment as well, and then during the beginning of sort of early next semester, we'll be working on the more sort of mechanisms, mechanical stuff like the control surface mechanisms, possibly the gimbal, the UGV deployment, etc.
Just waiting for that. Yeah, thank you guys. That's incredible progress, and we can't wait to see the 3.2 wingspan full scale process in the workshop. I don't know where we actually put it, but
On the ceiling, we'll put it on the ceiling.
Yes. Yeah, thank you guys. That's really good. Yeah, next up is Bryony presenting for the operations team.
Hi everyone, sorry that I can't be there today in person to celebrate the achievements of the team with everybody. I hope everyone's having a fantastic time, learning about everybody's achievements, and I'll be looking at the recording very soon, which hopefully you managed to set up. If not, I will hopefully get some really good updates on everything that's going on. I did really want to be there tonight. I'm going to talk about the key operations updates that we've had in semester 1. So I'm going to be giving an introduction to who we are, and then I'm going to look at our key achievements for each of these subsections of operations, and then I'll be talking about our future objectives for semester 2. So who are we? Essentially, operations is the heart of the team. Operations is essentially what will always be integral to the team despite any of the projects going on. So it'll be things that will still happen when we have new projects after Vulcan, things such as social media, which will always be there regardless of what's going on with the project, web development, finance, etc. So first I'm going to introduce the amazing team that we have behind operations. We have Dio as our finance lead, Ariana as our graphic designer, Oliver as our outreach lead, Mo, who does all sorts, engineering manager, inclusion officer, and also does the incredible videos on our social media, and Christine, who is our web developer also. And that leaves me, who some of you may have been lucky enough to meet, as the Director of Operations to oversee all of this. Additional to that, I also look at the whole project management for the team. This is something that's going to be looked into in more detail in the coming semester, alongside the other managers of Project Hex. Some of the key updates and achievements that we've had this semester include successfully recruiting our first ever operations teams, who have all individually produced some incredible work. First of all, I'm going to talk through some of the achievements we've had in finance. So we have successfully sent off our alumni funding. It looked incredible in the end, with all the help from Dio, as well as Balazs and Oscar. We've also produced a sponsorship pack, which is very nearly ready to send, subject to approval from the team lead. We have also, very excitingly, as most of you know, achieved sponsorship from 3DXR, and also from Monday.com. Further operations, specifically Josh and Balazs, attended our Advanced Manufacturing Fair on behalf of the team, making some incredible contacts and also securing more funding, for example from carbon fibre tubes. This was attended with SSI, who we are really excited to be working with more closely. If this hasn't been mentioned before in the meeting, SSI, the Sheffield Space Initiative, which is comprised of ourselves and a lot of the other engineering teams, so Sunrise and Stratos, etc. We have some really exciting things in the pipeline for semester 2 as SSI develops further. It's incredible for our business opportunities and improving our public image, which in turn supports everything that we do at Project Hex. Additionally, we've been doing a lot of background research for our outreach, looking at local school contacts that we have, and which ones we can be getting in touch with, looking at the types of activities that we can offer, presentations, etc. Additionally, we have been looking into attending an event in March called GUTS, which stands for Get Up to Speed. This is aimed at primarily secondary school children to inspire them to pursue STEM careers. Currently, our marketing team has graphic designer Ariana, who has been producing some incredible graphics for our social media, and we're currently in the process of looking for a marketing lead still. If that does appeal to anybody in the team and you would like to fulfill this role, please get in contact with me. Marketing is something that's extremely important at Project Hex, because when companies, the university, potential sponsors are looking at us, the first thing they see is our social media, and we really want to make a good impression, as well as provide updates for outsiders. Some of our successful posts this year have been incredible focus on Black History Month with Dominic, who gave a really inspiring story. If you didn't see that, go and have a look at it now. It's fantastic. It's on all of our social media. We also reported on the Advanced Manufacturing Fair. You can see Balazs and Josh there with the massive Mars rover that looks incredible at Airbus. We have the more recent 3DXR one, where we got incredible advice and obviously sponsorship from Ben, which I'm sure you'll know. Additionally, we've looked into other things such as World Mental Health Day. The marketing analytics say it all. We've had Facebook reach of over 2,500, Instagram reach of nearly 5,500 people in the past 6 months. One of our posts in particular had a reach of 4,100 people, and we're roughly averaging sort of between 500 to 1,000 views every time we post something, which is just incredible. If anybody here is not following our social media, please go over, follow us, like us, Facebook, Instagram, LinkedIn, and just spread the awareness of our project, as this is something that promotes the university image, and therefore the university want to invest more into us, so it's super important. Thanks. These are some more analytics from our LinkedIn page. You can see we've had a little bit of a dip this month. However, when we're posting more content next semester, I'm sure this will go straight back up. It's really interesting on LinkedIn to see the different types of social media posts that are preferred on there, and it's interesting to see which ones do better. There's also a comparison there about some of the other projects at university and how we're faring against them. Hopefully we can up those figures next semester and see ourselves second. The Dreamers first, but Sunride are pretty incredible, to be fair. But this doesn't mean that we can't do better than them. So Sunride, watch out. We've also organised some successful socials. Can meet loads of you at that. So the Dance Your Socks Off event, the burgers and bowling. Oh, I'm really hungry right now because it's like tea time on Wednesday and I'm just thinking about those burgers. Anyway, sorry for butchering. Yeah, and then we've also got the Christmas meal coming up this weekend, which can't wait to see you at, some of you at again. But yeah, here's the video that Mo has kindly produced from the burgers and bowling event. So if you could play that, that would be really cool to show everybody before that gets posted on social media.
Show me loving. I need your loving. 'Cause I'm drowning in something and I can't come out. So show me loving. I need your loving. Me, myself, ain't enough. It's like being a doctor or crushing heart. I want you to know how bad it hurts. If you get it inside along my heart. Oh, 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 are you dreaming of me now? The way I do. Oh, 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 are you dreaming of me now? The way I
Director, engineer.
This is blowing your mind.
Any quick words before he does it?
I'm ready. Half running out for a minute, trying to do this.
Do you still think he has it?
Collision avoidance, he's got this.
He's got this, he's got this.
Paparazzi, they're always following you around. No, it's like, he's warming you up. I'm pranking you. He's warming us up, he's warming us up. What's this? I'm done. He doesn't need to win now because we're going to win in 2 years' time in America. Exactly.
Within our web development, we've been successful in getting everybody who has filled the Meet the Team form out to be put onto the Meet the Team page on the website. Also, if anybody has got out to do this, it's not too late, please fill it in. I can also send you the link if you message me, no problem. We've been updating the blog, we've also added our swanky new sponsors. 3DXR, Boeing, Monday.com, etc. We can't wait to see more big names on there next semester. So as you can see, we've been busy over at the operations team, and I just want to talk through some of the instalments for semester 2. So I'm going to be implementing new project management tools to improve the current workflow of project tags. We'll also be looking to recruit the marketing lead. There'll be further work with SSI as they've got a new outreach team that's just in the very preliminary stages, and they'll be looking at attending events such as GUTS, schools, etc., which should be really exciting. We'll be optimising the website. We're hoping to secure some more sponsorship as well, and most importantly to everybody, we're going to have some more socials. One of the early ones that's already in the pipeline is Bottomless Brunch at Turtle Bay. That's definitely one of my favourites, and here is some pictures from one of the times that I went with the girls, including Ariana, our graphic designer. But yeah, so I hope this hasn't been too long. I don't know if I'll get a chance to go through and double check how long it is. Apologise for the stumbliness at points. I just recorded these as a first take, so hopefully they turned out okay, and yeah, I will see you all very soon. If I don't see any of you before Christmas, have a fantastic one, have a fantastic new year. Bye.
Yeah, so Toby, how do you want to do this? Do you do it from your media side?
Yeah, so am I coming through the speakers okay?
Yeah.
Cool. So yeah, obviously I'm virtual, so I'm not at the front. So I'll just run through some of the stuff the electronics team has been doing. So we've got sub-team leaders Ipeksu and Mia as PCB and then Power Propulsion lead. So they've been working on stuff like working out the workflow for the PCB production, and we've decided to go with a particular designer and then also ordering through JLC PCB. So that's great progress there. They've also been learning how to use the package as well, so that we can more efficiently design PCBs. And then Power Propulsion have been doing things like sizing motors and looking at like comparison between 12S and 6S and stuff like that. So I'll leave on to Ipeksu if she's somewhere I can't actually see anybody. So.
I'll get your eyes back in a second.
Hello, yeah, so for the PCB design, we firstly decided on how we actually want to do it and implemented it on using easy EDA, as Toby just mentioned. Yeah, you can't see me, but I'm here. Yeah, and moving on, we also started working on the carrier board PCB, which is going to be connected to the telemetry radio so that the connections will be correct, so that there are no problems when we actually start using it. This will also show if our PCB is working correctly and if the workflow is okay. Lastly, we also started estimating the sizing of our components, and hopefully this will help the structure team decide on the placement of where our components are going to be. It is currently estimated to be 150 millimeters to 250 millimeters, but this might change when we actually get the PCBs. Yeah, so I will be leaving it to Mia for the power and propulsion.
Yeah, thank you. So basically for power propulsion wise, we didn't, our progress made wasn't as much as for Aerostructures or Aerodynamics, because it took some time. So basically what we did was battery wise, because initially our initial idea is that we are going to use lithium ion and lithium polymer. But then afterwards, I think after the 3DXR trip, we come back, everyone's, the person in charge suggested us not to use lithium ion, so we're going to move on from that idea. And it's probably good because we wanted to spot well our own lithium ion battery, which is probably not allowed in the university. So we're going to move on from that. And then for motor wise, we found out that we initially wanted to purchase MN605 even larger based on what kind of batteries we are going to use. Then after, there's also a common grounding issue which we need to sort out. So initially we wanted to ground everything else together, which is the battery. We currently have 3 batteries now, one for Avionics, one for cruising, and one for takeoff. So we wanted to ground all the power everything together, but it is possible that, let's just say worst case scenario where something fails and the entire system is going to crash. So which is not ideal, so we have to like sort that out. So looking ahead, we're going to investigate between the difference between using a 6S and 12S lithium polymer, but based on what we see now, there shouldn't be much of a difference. That's something that we have to do. Then we also have to look into the power distribution fault, which is going to really help the team when it comes to battery management wise. And also, yeah, using it.
Toby, was there anything else you wanted to add to that?
Yeah, so I think other things that we're going through for next year is we're sort of aiming to have a sort of prototype carrier board which will actually interface all of the different avionics components sort of finished by the end of next semester. Because once we've got the design for that, it shouldn't take too long to make it. And then we're going to focus later on in trying to reduce the size of it and making it more efficient. And that's basically where the teams are going to head from there. So, thank you.
Thank you. So, last but not least, Avionics and Control. So, I'll hand you over to Jahir.
Hello everyone, my name is Jahir. I'm the Director of Avionics and Control. And well, I'm going to talk about a little bit what me and my team leads and my wonderful team have been able to do in these past 2 months. So yeah. First, our main aims and objectives of the Avionics team is to be able, for this particular case, for the US competition, design and implement an autonomous navigation system to give Vulcan this level of autonomy that we need for our mission. Also, we need to do a robust computer vision system that is able to detect, localize, and classify different objects of interest. Also, we need to be able to map a certain area during the competition. So we're also working on that. And this is only possible if we are able to communicate and analyze this data and present it to the judges. So the communication and interoperability between the operators and the judges is necessary, together with a ground control system that will let us see this relevant information during the competition, and also will be helpful as a debugging tool during the test with Vulcan. To make this possible, we divided our team in 3 sub-teams. These are the autonomous system team, the imaging system team, and the ground control system that is also has been fused with the communication and interoperability, making a more compact team. So, well, let's start with the autonomous system team.
Okay, hi, I'm Lucca. I'm going to talk about what we have done in the last 2 months in the autonomous system team. Basically, our goal for these 2 months was to implement a hardware-in-the-loop simulation of a basic path planning algorithm. And what I mean by basic is considering multiple waypoints that the UAV must go through, and static obstacle avoidance. Obviously, in the competition, we have to consider dynamical obstacles, but it's a much harder problem. For these first 2 months, we only considered static obstacles. For that, we divided the team into 2 sub-teams. One responsible for developing the path planning algorithm, and another one responsible for developing the simulation environment in which we can test the algorithm we developed. About the path planning algorithm, we were able to, basically, let me explain first what we have to do. We have a set of waypoints we have to go through, and we have to go through them in an order that's optimal. So how do we achieve that? First, we use RRT algorithm to calculate the shortest path between all of the waypoints that we have to go through, And then we use some optimization algorithm. In this case, we use a genetic algorithm, but we can use any other, to determine the best route between all these waypoints. I'll show you a video that probably will make it a little bit easier to understand. As you also will see in the video, the problem we have so far is that the trajectories that we generate, they're not feasible for VTOL because they have some angles that the plane cannot do. So that's basically our next step to correct these trajectories, considering dynamical constraints, the angles we can achieve with the plane. Here's a video showing the algorithm working. As soon as it loads.
It's obvious.
What? This one is in crash. This should be okay. Okay. Basically, these black dots that you can see are the waypoints that the UAV must go through. These things here are obstacles. They're just random. There's no reason why they're specifically there. What the algorithm is doing is generating random points in the graph and connecting them, and then we can use this information to, let me pause here, to determine the shortest path between the waypoints. In this example, I didn't use many points because it takes a long time to like keep updating the graph. But as you can see, for example, between this point and this point, this trajectory is the optimal one. Between this one and this one is just a straight line. That's how the algorithm works. It connects the random points to try to make determine the shortest one. Oh, sorry. I can just here is the resulting optimal trajectory using way more points than in the previous video. As you can see, like these first parts are okay, but this turn here is not very good. So that's the kind of thing we want to avoid in the final version of the algorithm, make it a little bit smoother so the VTOL can actually follow it. Talking a little bit about the second subteam, which is the simulation environment, we were able to implement a VTOL simulation using gazebo and Q-ground control. The problem we are having right now is that for the simulation to run and to test the software we developed, we have to keep sending the waypoints for the UAV to follow the simulation. And we are having some trouble doing that right now, possibly because our laptops are not fast enough and the simulation has to slow down, and then PX4 enters in some fail-safe mode and we can't continue doing the simulation. We're trying to see if we can use some university computers to run the simulation faster, or try to solve this problem in some other way, but it's basically our main problem right now is try to run a simulation. So obviously our next step is after solving this, we can run the software, and then we can run a hardware in the simulation. I'll show you some videos, guys, of the simulation. The left one is basically the drone just taking off and landing. It's a pretty basic video, but the right one is a little bit more interesting. It actually follows the points that you can see. You'll probably click around here, and the drone will start following the point. One thing also that you may observe, like soon in the video, if he stops sending waypoints, what the drone does, it actually starts circling the last one, basically because it can't stop doing flight, so it has to keep moving, and that's why it keeps circling the last waypoint. I think that's the one that does that. So basically we weren't able to achieve our 2-month goal, mainly because of the problems we were having in the simulation, but I think we did a lot, especially with the path planning algorithm and the simulation itself. It's a really hard thing to do, so shout out to my team. They did an incredible job in this 2 months. So thank you.
Yeah, hello everyone. My name is Dominic, and I'm lead for the imaging system. So yeah, in this presentation, I'll take you through our objectives and tasks as the imaging system, and then I'll talk about our 2 months plan and the challenges that we faced when trying to achieve this 2 months plan. And then after that, I'll talk about the success that we've had. So basically, the objective of the imaging system is to detect and then classify and localize 2 types of objects. One is the person in need of rescue, because as you know, this is a search and rescue mission. And then the second type of object is alphanumeric character. So this will be uppercase letters and numbers printed on a cardboard. And then also we have to come up with some sort of mapping algorithm to stitch images that you take from the air together and construct a 3D view of the competition environment. So to achieve all of those objectives, we had a 2-month plan, and then in this 2 months plan, we wanted to come up with a running YOLO version 4 code on Linux. So the YOLO version 4 is the algorithm that we use to detect people in need of rescue. And then another aim that we had was to design an alphanumeric character recognition algorithm. And then we also had to design physical alphanumeric characters, which we will use for training the alphanumeric character recognition algorithm and then testing it as well. And then another, lastly, we had to train and test the YOLO version 4. So after we made sure that the YOLO version 4 algorithm was working, we had to train it with images, and then we had to test and validate it on out of sample data. And then we had to do the same for the alphanumeric character model. And then we had to also do some initial work on mapping algorithms. So the picture that you see there at the end, at the corner, that's the alphanumeric characters, but with different letters and numbers on the cardboard. So trying to achieve these objectives, we had a few challenges, and one of them was because it's the end of the semester, so everybody is busy with assignments and submissions. So it was it was difficult to get the team together for a meeting. And then another problem that we had was so the algorithms that are available out there for detecting alphanumeric characters detect for text recognition, and they detect the whole word instead of single characters. So we had to find a way to make the algorithm detect single characters instead of the whole text. And then another thing that we had an issue with was the Jetson Nano. So we only have one Jetson Nano and with a team of 8 people. So it was difficult to have access to the Jetson Nano. So what we did was we came up with a way to remotely access the Jetson Nano from the Judge portal. And then despite all those challenges, we did have some success. So we managed to collect sufficient data sets with loads of images. So these are data sets for people, images, data sets for alphanumeric characters, and we'll use this for training and testing our models. And then we also managed to test a YOLO code on a Linux computer. So I'll show the video at the end of the presentation. And then when it comes to training our models, we managed to set up a meeting with the help of Balazs. Managed to set up a meeting with the university so that we can be able to use the high performance computers. So the meeting is on Wednesday next week, and hopefully they will allow us to use the computers for training our models. And then also we managed to come up with 2 alphanumeric character detection algorithms. So one is called EAST and the other one is called CRAFT. So we managed to test EAST, but it was only able to recognize the whole text instead of single characters. So moving forward, we're going to kind of tweak it to detect a single character instead of the whole text. And then also with the help of Oscar and Balazs, we managed to like secure 2 Raspberry Pi cameras. So each with like a 12 megapixel sensor. Yeah, so another thing that we managed to like achieve is for the design of the alphanumeric characters, we managed to come up with a list of suppliers and prices for paint brushes, spray paint and padboards that we're going to use to design the characters. Yeah. So the video that you see there on the screen, that's the yellow version for code running on a Linux computer. So the video is quite difficult to see now because it's kind of far away, but as you can see on the videos, you can see like some bounding boxes, like the yellow ones, blue ones. So basically on those bounding boxes, next to them there's like the class of the object in the binding box and then the confidence tag. So basically we want that algorithm to be able to detect people. So there you can see like we put a bounding box around Joe over there. So that's what we're gonna do. Yeah, and after that, for the video about the alphanumeric character recognition algorithm, we don't have it at the moment, but we're gonna edit and we'll edit to the Google Drive so that everybody can see it. Yeah, that's everything from the imaging systems team, and then I'll hand over to Jahir.
Alright guys, so not much left to say. Now the ground control station will take it from here.
Not much left to say, that hurts.
Sorry about that.
Hi, I'm Kian. I've been leading the ground control system subteam. I'll give you a little walkthrough of what we're doing. I'll try and be quick because I don't know how much time we've got left.
We're ahead of schedule, isn't it?
Oh, is it? Oh, I can talk. Okay, so our 2-month goal was to find some open source mission planning software and edit it so that people on the Avionics team could take what they were doing and then try and view it on a ground control system so that they could debug and get it working. So we wanted to get that done for around now. So the first thing that we did is read through the mission planning source code, which if you had a look at it, which I doubt you have, is thousands and thousands and thousands and thousands of uncommented code, which is always lovely. So we made really good headway reading through, documenting it. We then wrote some code recently to allow for waypoints to be inputted in the correct format. So this part here, this is how Mission Planner reads waypoints. So there's loads of different parameters. The main parts for waypoints, these bits here, which is the altitude, longitude, latitude, the things that you think about when you think of a waypoint. So we wrote some code that allows us to take some data, say from the controls team. We can convert the waypoints that they have so that we can put them into a log like this. So it can be played through in Mission Planner. You can see the waypoints. At the moment, this is only manual, so it's not automatic. You have to put the waypoints in through this system itself, and then it puts it in that document. We've done some basic editing of the GUI. There's a little text box there. You can see it says potato, like fun. And if you look, we've moved this thing. This is just a cheeky demonstration, so you can see that we can have that control over the GUI. We also, oh, what happened? There we go. We also had a look at the local interop. So this is one of the main parts of our team now, is making sure that all the data that we get from the drone can be sent over to the interop server, which will be visible for the judges. Obviously, judges looking at telemetry and stuff is mildly important. So at the moment, we've got that local interop server running. It's receiving inputs. Again, these inputs are manual, but when we get to creating our own ground control software after Christmas, we'll be implementing a feature inside the software itself so that it can do it automatically. We'll have to activate it through a button, I suppose, but we'll get to that when we get there. So yeah, at the moment it's manual, instead implemented into our custom software. Speaking of custom software, recently we've started work on actually creating it. So we've been using Dear IM GUI, which is what this is here, which lets us take and control the GUI that we want to use. Dom would have talked about it a bit more. I was told a bit pressed for time, so he's not talked about it now. But he's done some great work. And obviously, when we actually start to, after Christmas, looking at this properly, it will be really easy for us to actually create a nice looking software as well that's functional. But yeah, like I said, main development of this will start in semester 2. We've been working on usage guides, and this is something that I've been doing more than the rest of the team have been working on the programming side of things. These usage guides are going to be handed out to the Avionics team so that they can put their stuff into the software and see how it looks, hopefully maybe do some debugging with it. Like I was saying, Mission Planner is a business software for most of it, especially looking at the source code, so these usage guides come out quite slowly. This will probably come out after we're fully committed to actually programming our new ground control software. So while we're doing work on that, people can have a vague idea of what it will look like. It's more of a visual thing than a debugging thing, because Mission Plan is kind of nasty. Did we achieve our goal? While we haven't fully edited the software like we wanted to, we've gained a lot of information about how ground control systems work through looking at the Mission Planner source code. We know that when we're creating our own software now, if there's something that we don't quite understand, we know how to find that particular part of it in the source code for Mission Planner. Say we don't know how to get the map looking right, we can just go, right, okay, here's how Mission Planner's done it, can we improve, can we just copy and paste it, things like that. We've also done a lot of things outside of our goal, like I said, with the usage guides and the interop server. So yeah, we've made a little bit of progress on quite a few things. Another thing is, with the ground control station itself, there'll be a lot of data that needs to be presented, and if there's anything in particular that you as a sub-team would like on the ground control station itself, there's a QR code that will be on the end slide as well. There's some formatting things on that. So if you want, say, the role data to be on there, putting it as a high priority or anything like that would be really important to us as we go into creating our own software. You can read this slide, it explains what we want quite clearly. But yeah, so any particular parts that you want displayed on the ground control station or anything that you think we might accidentally miss, pop on the Google form and we'll get around to it. One other thing is that we have made programming conventions guides. So as we go into creating our own software, we have to then take all of the code from other softwares that are giving us information and make sure that it's all working right. If we can get conventions down, that makes our job easier. So that sort of covers like the compilers, libraries, data formats, units. So if somebody's using metrics and we're using imperials, then it goes wrong. So getting these conventions done is something that's going to be really important, especially for us as programming teams. These are going to be on the Google Docs. I don't know if they're on there yet, I think they are. But you can look through them if you want to. I know it's probably not as important for the structures teams, but it's there if you want to have a look and know what programming is like. Yeah, I think that's about it. I'll pass back over to you here. Yeah.
Yes. Thank you so much. I'm like so thankful for what amazing team I'm leading. My three sub-team leads and all the members have been doing an amazing job. I'm truly proud of their work. So now I'll show what we're going to do for the next 3 months. Each sub-team, we like to have these batch goals so we can measure them at the end of these periods to see if we actually did them or not. For the autonomous teams, it will be to do a hybrid in the loop simulation with path planning and collision avoidance. This means that we'll have a full simulation where Vulcan will be able to do something similar to what it's actually going to do in the competition, to go through the waypoints and to do collision avoidance with these static obstacles. The imaging system will test the system with real flight data thanks to the UAV, I'm probably using the UAV that 3DXR gave us and a Raspberry Pi camera to get flight data where we use the actual images of the alphanumeric characters to test them and see how our algorithm performs. And the ground control station team will propose and implement a minimum viable product of the ground control station. That means that together with all the feedback that you guys will hopefully provide of what things you want, like what's vital for you to be there in the ground control station in order to debug or in order to visualize if Vulkan is actually working, or this test UAV that we will have. From that whole list, a subset of those features will be selected, and then we'll present working ground control station software with these with vital features. This is for the next 3 months, so roughly 15th of March. But then we'll have our semester 2 goal after the 1 year mark is to hopefully have a full system where these 3 parts of the Avionics team will be working together in a full simulation, where we can present to you basically how the software side of the operation is working, like everything together, how it's going to be in the competition. The only thing will be basically to put that same software in a flying drone, and it should be at least a first prototype of this avionics system. I think that's it. Okay, thank you.
Before I give some closing remarks, these are your tasks over the holidays. So first of all, genuinely relax, get a well-deserved break, and just enjoy your holidays. We're not going to be the official policy. We're not going to be sending anything. So I'm going to make that really clear to the management team that nothing will be set, and that is due by the end of the holidays. Obviously, if suddenly something appears in the drive that just sort of was done by someone, we're not going to be angry, but that's entirely up to you. If you want to work on it, you're welcome to, but there's no expectation to. Obviously, exams are coming up, so revise for them, because Hex is cool, but if you fail university, then there's only so far I can take you. And just be ready for a really busy first month back, because Aerostructures is going to be doing a month-long push to get that full-scale prototype together. Obviously, as Jahir mentioned, that 3-month goal is really more of a month at the start of the next semester. So yeah, it's going to be really, really intensive. It's going to be going up from here as we get more and more components to work with, more and more tasks to do as well. So yeah, the final thing I just wanted to say is, genuinely guys, like half a year ago, when it was just me, Toby, Josh and Oscar at the end of last year, we couldn't have imagined that in half a year's time we would have a team of 50 with so many sub-teams all doing completely unique things, using very specialist skills, working together, going on socials. I mean, we had a whole year of just COVID, not doing any socials or anything. So genuinely, I'm so proud of you guys, and like genuinely, it means so much to me that you guys are all working so hard. So thank you very much, and enjoy your holidays.
That's going on the Instagram account.